Hello children. So let's now discuss carboxylic acid derivatives. So when you replace the OH of our carboxylic acid, which is RCOOH, is our general, how we write it, we generally represent an carboxylic acid with RCOOH, and when you replace the OH with atoms or group of atoms, we get carboxylic acid derivatives. In this uh, chapter, we'll basically discuss four set of aliphatic carboxylic acid derivatives. So let us look into what they are. So when I replace the OH with Cl, okay, and I know this is we had discussed just in the last class, that is, you just treat it with PCl5, you remove POCl3 and HCl, I will get our C double bond O Cl, which is our acid chlorides. Okay, this is the first derivative we will discuss. Then we have acid anhydrides. Okay, so here this is where we are replacing OH with our C double bond O. Okay, and here this reaction, this is typical, is in presence of phosphorus pentoxide. Then when you treat your acid with ammonia, we end up getting the acid amide. Okay, so I have NH2 here. Then finally we talk about our esters, R C double bond O R. Okay, and here you can also write minus H2O, because that's this, it's a product that comes here. Here this is a typical with an alcohol, and you remove the water, you get the esters. So let's go a quick roundup of the nomenclature. Okay, so we start with acid chlorides. Okay, so now that is a very common, referring them to as acid chlorides is a common name. For example, if I had CH3, C double bond O Cl, we call this acetic acid. In the Varnonda, we say this is acetyl chloride. Okay, but now IUPAC name, okay, in the IUPAC system, this is the parent was ethanoic acid. Okay, so we drop, what we do is we drop the IC, you remove that, and you add YL, and you add the corresponding whatever was the halide that was there. So in this case it will be ethanoyl chloride. Okay, similarly, if I had a benzene, you have C double bond O Cl. In this case, we will say this is benzoyl chloride. And the same way, if you have some substitution, the basic functional group is our the substituted acid chloride, and that is what we will give it as the basic parent, and the parent name will be with that, and then you add the substituents, like if you had a methyl group or any other groups, like OH or conjugal, like for example, let me take CH3, CH2, CHOH, C double bond O Cl. What would be the name? So we here in this case we would take 1, 2, 3, 4. Okay, this is butane, that's the parent hydrocarbon, and Of course, I should not be numbering it in this way. I should be numbering it from the functional group. 1, 2, 3, 4. Yeah. So the parent is butane. So it should have been butanoic acid. So it will be, in this case it will be butyl butyryl. Okay, that will how it will be, butyl chloride, and we say it's in the alpha position, so this is alpha hydroxy. So this is my common name. Now if it was if I was going for the IUPAC name, it is butanoic acid, so it will be butanoyl, so NOIC will become YL. Okay, butanoyl chloride, and this will be in the second position, so 2-hydroxy butanoyl chloride. So this is how the naming will be there for our acid chlorides. Now what about for those in which you have like if you have your cyclic ring, okay, you have cyclohexane and you have a COOH, okay. So this is cyclohexane carboxylic acid. This is the name, how we name this, okay, cyclohexane carboxylic acid. Now if I had removed OH and I have Cl here, the name will be cyclohexane carbonyl chloride. Okay, so this is how it would go. Even for your another example, suppose I have the benzene ring and I have CH2 C double bond OCl, which is a bit different from what we have here. Okay, in this case, how do you name this? The name will be we take the ethanoic acid, that is the parent here, so it will be ethanoyl chloride. Okay, and the substituent in the second position I have a phenyl group, so 2-phenyl ethanoyl chloride. This is how the IUPAC name would be. Okay, now let's go to acid anhydrides. In the case of acid anhydrides, it's just all you do is you add, how do you say, anhydride to your as a suffix. Okay, so you will remove that, like for example butanoic acid, you remove the acid and you will write butanoic anhydride. Okay, so let's take the simplest one, which was our acetic acid. Okay, in acetic acid, if you had removed OH and you put again O, C double bond O, CH3. Okay, so this is acetic anhydride, which is a common name, and so in this case it will be ethanoic anhydride. That is my IUPAC. This is my IUPAC nomenclature. Now suppose this is a simple one because you had both species on this is basically from 2 molecules of acetic acid. So now suppose I had a mixed anhydride, okay, that is CH3 C double bond O, and I have in this end I have say one more. Okay, here so we take the bigger molecule, which or the one with that contains the more number of carbon atoms, and you take that as the acid part. Okay, the main acid part. So here it is propanoic acid, so we say this is propanoic anhydride, but to distinguish that it is a mixed one, we say it is ethanoic propanoic anhydride. This is how you would name it. Okay. Similarly, if it was benzene, you would say benzenoic, propanoic, anhydride. So that's all about anhydrides. Let's now go to amides. So amides means when I have replaced it with NH2. So we remove the IC acid part. Okay, the IC acid part. Sorry, OIC acid. OIC. You have to remove, like, for example, if it is as ethanoic acid, we will remove the all, like, you will remove let me write that ethanoic, you will remove OIC, and I will write amide there. Okay, we say it is ethanoic acid. Who is that? CH3, C double bond O, OH. Okay, so when I make it CH3, C double bond O, NH2, we will remove oic acid completely and we will write ethanamide. Okay, this is how the name will be. If it was if it was a benzene ring there, that is C6H5 and CONH2, C double bond O, NH2, we say this is benzamide. Okay, and if you have a cyclic group, it will be cyclo. So now suppose I have substitution on the N. Now usually I can, now this is a primary, these all are primary amides. Now now I know I can replace these hydrogen on nitrogen, right? So there you have substitution on the nitrogen. So there you have to specify NN. For example, if I have CH3, CH2, CH2, C double bond O, N, H, CH3. So this is a secondary amide where I will name it as N-methyl. Okay, and the 1, 2, 3, 4. So it is but. So butan amide. So N-methyl butan amide. This is a secondary amide. Now if I go for a tertiary amide, that is, I have two. Let me take both are the same. I'm just writing both are. You can have different also. You can have CH3 and how do you say, C2H5 or anything, whatever be the substitute, whatever be the alkyl substituent. What is C double bond O? Let me take the same case, or let me take even there's a substitution here, CH3, CH3. In this case, my parent will be 1, 2, 3, that is propan, right? Propan amide, because it comes from propanoic acid. And then now you go, okay, so we have N, comma N, okay, and all the three substituents are the same. So N, comma N, comma 2 trimethyl propan amide. Okay, now the last one will be our esters. How do you name esters? In esters, you would replace our so again you have to first see the acid counterpart, and if it is oic, so you have for example ethanoic will become ethanoate, and then the alcohol, because you know that it comes from a acid and a alcohol, so the alcohol counterpart will be the alkyl group, will be named as the corresponding alkyl, and the acid the acid would be, you would remove the IC acid, that is IC acid you would remove, and you would give the 8 to it. So let's look into it. For example, I have CH3, CH2, C double bond O, OCH3. So this was prepared from methanol and CH3 CH2 C double bond O OH. Okay, so that is, here it is a propanoic acid and methanol. Okay, so what would be the IUPAC name of the corresponding ester? In this case, we say it is methyl propanoate. Okay, this is the name. Similarly, if you that's how it would go. Okay, let's take a one with the aryl group, or yeah, so in this case, what would be the name here? I have COOCH3. Yeah, in this case, the name would be methyl. Okay, because this is for the of the ester part. Okay, and then 2-methyl to show that there is a substituent on the acid counterpart. Okay, benzoate. So with that, I'll stop here. So we're done with the nomenclature. Thank you.